Hello and welcome back to Compiler Programming. Today I want to continue working on our embedded debugger setup. If you haven't watched the last video where I implemented that stack tracing, I highly recommend to do that. I will link it in the video up there. And basically what was happening in that video is we added support for going through the stack ourselves, so do the stack inviting. There were actually a few things that I did not take into account, so that was fixed in subsequent pull requests, and I'm gonna quickly walk you through that. So when we try to get to the next stack pointer, I originally only was looking at stack reserve, so how much stack space each function needs. But there is also the part about the saved non-volatile registers for this function, and this basically needs to be taken account because those non-volatile registers are actually pushed on the stack. Maybe I can open the debugger and show you how that looks like. Just a second while Visual Studio opens up. Yeah, we have the breakpoint in the right place, so we can take a look. Starting up, right, disassembly, and we can step into the function. So this first function is not really interesting, but we see that it has 28 hex. So what is that? 32, 40, I guess, reserved, if my hex counting is correct. Reserve stack space, and then it calls this other function. And this is more interesting. So here you see this instruction called push rbx, and what that does is that it saves a register to the stack, and then before the function ends, before we do return, we pop the register of the stack. So we kind of restore the original value. So when you enter a function, there could be some values in registers, and when you exit, you need to restore some of those values according to the API or the calling convention. And since this actually changes the stack pointers, these pushes need to be taken into account. So this is this code here. So now we count the number of pushes and we do this change. So that was one problem that needed to be addressed. But another problem was actually connected to the this return, right? So when we do, let me go back. When you see this instruction, return ret, what that does is it actually also changes the value of the stack because it pops the return address of the stack and goes to that address. So if we go over here, okay, we have an exception, so I can't actually show you that. But basically, yeah, return pops the address of the stack, and that means we also need to change it. Finally, there was also a problem with checking the instructions, but that is not that important for us at the moment. Okay, so that are the changes since the last time, and today I want to start working on sort of REPL for this debugger, and this is where we're gonna start. I guess the idea right now is that when we encounter an exception, right now we are just saying, okay, this was an exception, and we let everything explode. But what we could do, at least let's start only in the user breakpoint section, what we could do is we can enter the Read-Eval-Print Loop, and same way as you would have in something like GDB or LTB, and you could issue commands to the REPL. I'm not going to implement a very good REPL. In fact, it's going to be very, very basic because I don't want to go into something like readline implementation, which is unfortunately very hard on different platforms. So I'm just going to use fgets and hope for the best. But we should get somewhere. So here is what is going to happen. For now, I'm just going to do it in line, and then we'll see how it goes from there. So first is we need to have a loop. Okay, we're gonna have a small buffer here. We'll just say that this is gonna be char line buffer. I don't know, 80 characters, whatever, 156 characters. Doesn't really matter. Okay, now we do what? We need to read some characters into, so we need an infinite loop here. Then we read some characters. We say f gets std in. Actually, I don't remember the argument order of f gets, so let's check that out. So f gets cpp CVP reference is usually pretty good. So we have char star string, then count, then stream. Okay, so stream actually goes last. That is okay. We do line buffer. Then we say count of line buffer. So let's make sure that we don't overflow it. Actually, we probably want buffer -1 because we want the let me quickly check. So char star int count was return star. Okay. So I think it will get the 0 there. So I guess that's fine. Char star command. Okay. And now we can do the following. So if stairs cmp command pt is 0. Okay, so we have backtrace. I can do a full form of backtrace. Then we're gonna do this. Let's print the breakpoint before. User breakpoint hit. Okay. We can do else if I don't know GDB at all. I had never really used it, so let's do like GDB cheat sheet or something. Okay, I already clicked on this before. So how do you print the registers? Registers, so it's info registers. I'm not sure I want to do multi-word ones right now. So I'll just do registers, and then I will think about parsing multi-item commands. Okay, so registers. That's good. I copied it, but I didn't do it right. Okay. So register state actually is going to be connected to the stack traces eventually, because you can figure out what was the register state in each step if the code was compiled with the debug information and debug setup. I'm gonna show you in a bit what it looks like. I'm not sure if it's gonna be in this video, but eventually we'll get to that point. So we can support these for each stack frame. For now, this is only gonna work for the current stack frame, so it's not great, but we can start here. Okay, and then we can do command continue. Is it continue? Is it like run or something? Continue. So it's cont. Of course it is. Well, let's do that. Support it like this. It's also very inefficient, but I honestly don't care for this code. This is a REPL. It can be as inefficient as it really wants to be, so this is fine. And right, so we get to here, and we should never get to this code. So something like unexpected exit from debug REPL or something like this, because we should only exit the REPL if we get continue or if our process is dead. Something like that. Wait, maybe what I should do actually, let's get back to gets and look at null pointer of failure. Okay, FEO, blah, blah. So we are actually gonna do this check first because on failure I probably also just want to continue for now at least. Okay, what is happening here? An extra one, we don't need the else here. And this is correctly unreachable code. Well, if you say that it's unreachable code, that's I guess fine. Okay, so that is good. Now we can try to run the tests. Technically nothing should change because our tests don't depend on this code. I'm not even sure how to write tests for this stuff. They would have to be very unit testy like, so I'll like just pass stuff in this function and expect things to happen. But testing also the streams is really awkward in C, unfortunately, so I'll need to think about how to test this code, not manually. But for now we can just go ahead and do this manually. Let's get to FizzBuzz, our favorite test, and I'm going to, well, let's break here maybe, or let's break in printing. So there is this debugger statement that is again is actually implemented in our code. So this debugger is just outputs a CC instruction on x86. And since we don't support any other processors, that is all. Okay, so well, let's try to run tests. Ideally, what should happen, we should enter the REPL, but I forgot to put in some prompt. So let's actually do that. We can say f, is it f puts or something? Don't use those functions very often, so I don't remember any of them. CVP reference, yeah. So we put, okay, that's fine. F puts, we would call it MDB. Std out. I have no idea if this will actually work, or we do need to bring some kind of readline implementation, but that is a start. Okay, so as you can see here, we have an handle exception, user breakpoint hit, and we have our prompt. We can sort of even edit our prompt, so that's okay. I think things like copy paste, yeah. So selection is gonna be awkward, copy paste is gonna be awkward, but that is okay for now. I don't care that this is a bit clunky. What I forgot to do is to add a case for unknown command, but let's test the commands that we have. So we can say registers and exactly nothing happens. That is quite unfortunate. Okay. So for debugging, we will also just output the command that we got. And else, actually, let's do it that way. But can do printf, I guess. Printf unknown command. I think I'm using strcmp correctly, but you never know. So let's try this again and see if we get into unknown command case or not. Unknown command bt. So does that mean that I am using this incorrectly? Wait, I'm confused. Spear reference, strcmp. I mean, I thought I need to compare it to 0. This is... Oh, right. The problem is that we get a new line at the end of this, I think, right? The file will contain that new line character, right? Okay, so that's a problem. We get the new line, and that means I need to get rid of that new line, which what's the best way to do it? Well, let's just turn it into a slice and work with that. It's also going to be faster to compare, but that doesn't really matter. Okay, slice, command C string. I would say slice command. Well, actually, that's fine. So we do like this. Now we do need to handle this error. Okay, if that happens, we just gonna do this. Ideally, I would like to here's how we're gonna do it. We're gonna put this code in here, and we're just gonna do break. And here we're also gonna do break. I need to move this comment where it belongs. Okay, so command is slice from C string, command C string, and now we're gonna do command is slice trim of command. So this is gonna remove white space on both front and back, I believe, if I remember my code well. And now we can do the comparison. So slice equal command slice literal continue. This is slightly longer because I need to write this slice literal stuff. I should probably do a generic macro to fix that, but for now it is what it is. So let's break, else if we can copy now this code, and we have backtrace and bt. That should print the backtrace. Else if slice equal command slice literal registers. We are gonna do the registers. Right. And else we are going to say that we have no idea what you're talking about. So apparently it's not trim. Starting white space, slice trim white space. Okay, so just the wrong name. And we can use the C-string version here just for convenience. Okay, that looks good. Let's see how we are. Okay, foo unknown command. That is great. Now we can do bt, and here's our backtrace. This looks. Does it look correct? So interesting. 4156. So this is very interesting. Why does it show this code in here? This backtrace seems a bit worked. I need to look at this separately. It sort of has nothing to do with the with the code that we just wrote. It's just wrong. But in here, so this is correct. This one is correct one, and this one I need to figure out what is going on there. So I think the problem, so this stack entry is taking in the source location of the macro instead of the code that is calling the macro. And that is not exactly nice. I need to figure out what is the right thing to do with the macros. But yeah, that is sort of not connected to the REPL that we're building. So the whole point is now we can do this multiple times. And we can do the registers, we can print them, and we do count, and we are, yeah. So this is fine. And basically, we are hitting the breakpoint again here. So we printed one, and so we are, our breakpoint right now is in this print. Print is called within the loop here. So every time we do continue, we will get one iteration of the loop. Right. So that is very, very nice. And again, yeah, we can do registers and we get the registers. This is very, very nice. Okay, so I guess let's continue. I will commit this code here and let's say episode 159 implement basic debugger REPL. I need to look at what GDB does with standard output, because you sort of have a mixture of standard out and the debugger stuff. I guess debugger is connected from the outside, so it overrides the standard out. I'll need to think about if this is okay or there's a better way to do it, but for now, that is perfectly fine. Okay, what else can we do? Well, one thing that we can do is we can make this generic, but it's not very interesting. Maybe like I will figure out how do I want to handle all the other exceptions. Like I probably want to get the debugger on every exception, but that will require slightly organization here, which is not very interesting at all. So what could be cool is if we could print the variables that are available in this scope. That may require actually some changes to how things are done. In particular, I probably will need to change value.h instruction. So right now we have compiler source location, which is good. We have a source range, which is how we figure out the stack trace. But what we don't have here is we don't have a scope. And this is an interesting question. So if we add a scope, we add quite a bit of bloat to the size of this thing. I mean, it's not exactly light right now anyway. So maybe that's okay, and I'll later figure out how to deal with that. So I'll do scope, scope. But the problem will be that none of the places that are generating instructions are currently propagating this, which means I would need to go through the whole code and make that happen. And I don't want to really. So for now, I'll just make it work specifically for inline machine code bytes. So whenever we call this, we will capture the current scope and we should be able to then do stuff. For that, we will go to source.c. We will go to inline machine code bytes, lazy proc. That sounds Perfect. So we have this instruction being generated, and I can do scope is context scope. Okay, so now we do have scope, and okay, we can go back here. Let's look at how this command is called in GDB. Is there something like locals? So there is info locals. Okay. Well, we can try to make that happen. I will again not do 2 words for the command, instead it's 1, just like registers. So we'll have locals here, and we would do if right. So what we want is we want to get the instruction for this place, and the instruction is here. Yikes. So I need to take this code and somehow make it possible to call it in a different setup. Okay, I will just copy paste this. I don't want to spend too much time on trying to figure out how to factor this better for now. So first I want to make it work. So we'll say Win32 instruction for address. And in here we don't need stack pointer, I believe. Okay, so address. Right. Return instruction. Return 0. And here we would say let's do like this. Okay, so now we can say instruction is REP in 32 instruction for address, like so. And we say if not instruction, then we would say sorry, no debug information for current IP is available. Okay. Else, actually this should be the other way around. I don't know why I did the negative condition first. I guess that's how my brain thinks about this stuff. Anyhow, if we don't have an instruction, and we need to have instruction, and we need to have instruction scope, right? And if we do, then I think for now I'll just do scope print names of instruction scope. All right. So we have source C, we have source H, and we have scope, print, I cannot spell, is scope, print names, right? So let's make a forward declaration for that. Somewhere right here. Okay. Well, let's see if that is correct. And running the tests, we should get the debugger. And did I? Yeah, I did change the command. So we should say locals, press enter, and look at that. So for now, we cannot inspect the values of each of the variables, but we do know what they are. And there is this whole also problem with, like right now, the code does not have proper register allocation across different statements, so we should not run into this problem. But technically, depending on where you are in the code, the actual storage of the variable may change. So at some point it might be in a register, different point might be a stack because it was spilled and so on and so forth. But for now, that's not the problem. So we could go on and try to do more stuff. But continue. Yeah. Okay. Right. What else do I want to do? I guess let's try to print one of the values as the last thing we are gonna do today. And how do I do that? Print last value, print expression. So I guess I want print expression. And okay. So, okay, we say else if slice starts with command slice literals print space. That is a very bad parser code. Do not repeat after me, but I just want to make progress, so that is going to be fine. We will say slice variable name is print or slice sub something like this command yeah, this is pretty terrible code. I need to do something better about than that. But we want, essentially I'm trying to extract the name of the variable. And for now, let's just do slice print variable name. So for now, I just want to know that this works. We do print, I don't know, X. Okay, so it actually worked. We successfully extracted X. That is good. So now we have the variable name. We can do value star value is scope lookup. Not sure which I want to do. Scope lookup. I guess I want force. Maybe. Is there just a scope lookup? Yes, there actually is. So I think I want that one. I don't want to generate any code or anything like that. So we do scope lookup command scope and variable name. Again, we need an if. So if not value, then we say defined variable blah blah, right? Okay, so here I'll have to do like this and slice expand printf of variable name. So we don't know what the variable is. Say I want to put it in quotes or something. And doing the thing where I do the negative version first. Okay, so if we have not found it, then it's gonna be a defined variable. If we did find it, this is where it becomes a bit awkward because right now I don't have a good way to print stuff. So there is no generic routine that would go on and print an arbitrary value. That is something that needs to happen. So for now, I will just do, here's what we're gonna do. Prelude, FizzBuzz. Okay, so integer is an S64. So what I will do is I will have a routine that is explicitly working with S64 values, and then I will figure out how to do it for everything else. So I'll say if descriptor, if value descriptor is descriptor S64, else to do support generic printing of values. Okay, so we know that it's in a 64. Now comes the fun part. We also need to check where is it actually located, right? So is it on the stack? Is it inside the register? Is it a static value? So what's the deal here? So let's do that. We say value storage tag, and I'm just gonna go to storage tag register. That's not how I wanted to. Okay, that seems a good thing I can steal. Okay, let's get book here. That routine definitely should be extracted into some other code, but we are just getting something going. Implement printing this storage type. Okay, so we are interested in the register. And in particular, this descriptor is 64, so we want this to be a register 64. We can do something like assert value storage byte size to be 8 bytes because it's a 64-bit integer. And now I can do so how that would look like. So we have code to print registers. Unfortunately, this is not an array. I think they are located one after another, so I could try to index that as an array, but that would be it's technically unsafe because the definition might probably change at some point. So unfortunately, what I will have to do is I'll have to take this code and then I would have to do another switch. And I would need to say switch on value storage register index. And then this is gonna be so terrible. This is a place where you really wish that C would have some better metaprogramming facilities, but hopefully we'll get that in this new language. And now I know which kind of things I do want to have, so that's good. Anyhow, we need to go to generated types, and we need to get to register enum. Register. Yeah, that thing. Ooh. Also need to fix my editor to be better at this kind of stuff. This is the same thing, this is also the same thing, this is also the same thing, and this is the same thing. They shouldn't be... Don't think they all should be 4. So maybe also definitions are wrong. Anyhow, this is not what we're working on right now. What we're working on is trying our best to do this stuff. Ding, 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 ding. Lots of cases. So right, the XML ones are not even supported at the moment. So that's not something we will do. I still need to list all of these registers because I have this set up in the MSVC compiler that will yell at me if I try to use unknown enum. So here we will do another to do, and we say support XMM registers. Okay. And I guess it's a dword 64 register value. Let's just say 0 for now. And in here we would say that register value is context record array X. Oh, it's like this, Rex, right? And then we do break. Boom, 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 boom. So this is what we need to do for all of them. Just very, very awkward. Okay, 15, 14, 13, 12, 11, 10, 9, 8, RTI, RSI, RP, RSP, RPX, I guess. RPX, RTX, in RCX. Okay. So now we are ready to print this. This is the register value. And I'm just gonna print it in hex. There is lots to do here with the printing modifiers, like printing as hex, printing as decimal, printing as binary. All of those things need to be, of course, figured out, but that is something that I can do slowly and offline. There is no really interesting code there. Scope, yeah, it's instruction scope. So we need to do the same thing here. So that's gonna be bad. I hope I did this correctly. If value, is this balanced? Variable name. Yeah, something like that, I guess. Scope entry to value. Fine. So scope entry, we would say if scope entry is not scope entry tag value, then panic do support other scope entry types. It's always useful to sort of do this skeleton of the code and just plug it with to-dos and panics and whatever, and just have something to also show you what you're missing, what you need to do, and give you just a better understanding of how all of this support's supposed to work, as opposed to just trying to plan out this whole code ahead of time and try to figure out what you need to do. Scope entry value. Okay, so that works, or at least that builds. Now we are ready to try to do stuff. So first local, so we can look at what is defined, and I want something that is in the register, because anything else is gonna be very angry at us if we try to look at it. And what is in the register is integer. Do we even have it here? The order is sort of random because oh, right. So this is awkward. I mean, it is correct in the sense that this is how the language works, but for debugger, this is problematic. And what's happening is that the macros are hygienic right now. So that means that in here, I don't actually have access to the values of the outer scope where debugger was called from. And since I don't have the values of that scope, I can't actually print them in the debugger, which is like, that's not particularly great. So I either need to maintain the information that this is a macro, and then I could like somehow step out of the macro, but this is not this information will not be part of the standard information from the operating system, so I need to maintain it myself and figure out how that's supposed to work. All of that is very, very awkward. So it is possible that I can't actually print any values because none of these will be in registers. They will be, I guess, static. So you know what we'll do? What I will do now is instead of printing the value, I will probably just print the storage and call that done for now. And I said I need to think about how this whole macro situation is gonna work out. So what we will do is in here we'll take all of this nice switch statement, right? Does that build? Illegal case. I guess. Wait. I'm slightly confused. So this is this case. This is this switch. So here. I need to terminate this. And what I was going to do is I was going to do value C and storage. There was a way to print the storage here somehow. Yeah, it's called print operand, which should be called print storage really. And it's a separate topic. What we can do is we can do print operand. We don't even need to do it only for 64. We can just do print operand. And it's going to be value storage. All right, that is not an unknown function. That's okay. Let's try like that. At least I should be able to inspect where each of the variables is stored. This is not perfect, but it's better than nothing. So let's try to look at main. Right, unknown command main. That's because that should be print main. Main is not a value. Yeah, right. That's because that should be tag. Sometimes the comparison rules in C don't make any sense. I'm comparing a pointer with a enum. Like that never works. Like, I can't imagine the situation where it would work. I mean, I guess in something like embedded software that might make sort of sense, but anyhow. So what I wanted to do is print main. Unsupported immediate size when printing. Ta-da! I think I haven't looked at that function in a very long time. Right, so main is a function. All of this needs to be changed, honestly. What I want, let's just do the dumbest stuff possible and print something. Each storage. Okay, let's do even simpler thing than what we were originally doing. We will not do storage. So this is also to do here. I need to fix the print operand function. But I don't want to do this on the video either because it's going to take forever. And instead, I'm going to say if value descriptor name then slice print or printf. I don't know how GDB does that, to be honest, but I want to show the type of the value somehow. Well, let's just do it. Okay, percent pre-slice slice expand printf value descriptor name, and then to do print value, and then actual value, and then here we'll say we just want new line, right? So that's going to be puts and empty, and I will for now just say that it's always 0. So I want to get to something like this, right? Where you have the type and then in braces you would have the actual value or something. That I think would seem reasonable enough. Does that build? Scripter name. Okay, let's at least make that happen. So locals and print, let's print the type because type definitely has a name. Support printing generic values. So, okay, yeah, so that's actually wrong, but this is correct. So we know that F64 is a type. I don't want to do print names. So let's try to do it this way. And then we say print U64, and U64 is a type. And for now, we don't know what the value of that type, but we can do stuff here. I don't even know what we exactly will print for type, but we can print stuff. Right, I guess that would be about it. This video was going for long enough, and I feel a bit sad that we weren't quite able to get to all of this printing here, but as I mentioned, there is just a lot of very boring switch statements and fixing stuff. But all the bases here, we can get to the type of the variable, we can get to where it's located. If it was in register, we would be able to extract it from the register. So the idea is, instead of looking at the current register value, we're just looking at the value at the point where it was when the exception happened. We have this to do about the fact that we need to restore registers for each of the location in stack trace. But all of this is going to come later. For now, we have the basic REPL, we have super hacky parsing that kind of works, that still needs to be improved. And this is already getting to a point where pretty soonish, I'm going to have a debugger. I will be able to actually write some code, stop a debugger, inspect some things, and get some information out. So that would be all for today. Thank you very much for watching, and hopefully see you next time.